Hello friends, welcome to my channel Scientist Words. I'm your friend Ashwin. Today we're gonna talk about time travel, science fiction or future reality. The mind-bending physics explained in this video. Welcome temporal explorers. Today we are diving into one of the most captivating concepts in science and science fiction, time travel. From H.G. Wells to Back to the Future, the idea of journey through time has captured our imagination for centuries. But is it just a fantasy, or does modern physics offer any hope for what would be time travelers? Buckle up, or should I say, power up your flux capacitor as we embark on a mind bending journey through the science of time travel. Before we can talk about traveling through time, we need to understand what time actually is, and it's weirder than you might think. In physics, time isn't just a ticking clock, it's the fourth dimension of our reality, interwoven with space in what Einstein called space time. And here is the kicker, time isn't absolute. The flow of time can change depending on your motion or the gravity around you. Even the concept of now is relative. Events that are simultaneous for one observer might not be for another. It's like realizing that the rule book that you thought governed the universe is actually written in invisible ink that changes depending on how you look at it. Believe it or not, we already know of a way to travel into the future. It's called time dilation and it's a consequence of Einstein's theory of relativity. The faster you move, the slower time passes for you related to someone standing still. This effect is real and has been measured. Astronauts on the International Space Station age slightly slower than people on Earth. There is also gravitational time dilation. Time moves slower in stronger gravitational fields. These effects are tiny in our everyday lives. But if you could travel at the close to the speed of light or orbit a black hole, you could experience significant time travel into the future. It's like having a natural time machine built into the fabric of the universe. Now, what about traveling to the past? This is where things get really speculative. One idea involves wormholes, theoretical tunnels through space-time that could connect distant points in space and time. Originally conceived as ancient Rosen bridges, the idea of traversable wormholes has been a staple of science fiction. But here is the catch. To keep a wormhole open, you need something called exotic matter with negative energy density. We don't know if such matter even exists. Creating a wormhole would require astronomical amounts of energy. It's like trying to build a bridge across the ocean using materials we haven't invented yet. Another mind-bending concept in the world of time travel is the closed time-like curve (CTC). This is the path through space-time that returns to its starting point in time, essentially a loop through time. Kurt Gödel, the famous logician, found solutions to the Einstein equations that allowed for CTCs in rotating universe. Another idea is the Tipler cylinder, a massive infinitely long cylinder spinning fast enough to twist spacetime around it into CTCs. While these concepts are mathematically possible, solutions to Einstein solution equations, they require conditions that probably don't exist in our universe. It's like finding out there is a loophole in the laws of physics, but exploring it would require rewriting those laws. Even if you could travel to the past, we immediately run into the mind bending paradoxes. The most famous is the grandfather paradox. What if you went back in time and prevented your grandparents from meeting? Would you cease to exist? Then there is the bootstrap paradox, where information or objects can exist without ever being created. Some physicists like Igor Novikov propose that time travel might be possible, but that paradoxes are somehow always avoided. The self-consistency principle. It's like trying to write a story where you are both the author and a character, and the plot has to make sense no matter what you do. When classical physics gets stuck, sometimes quantum mechanics offers a way out. Some interpretations of quantum mechanics suggest that particles can exist in superimposition of different times. There is even an experiment called the wheelless delayed choice experiment that seems to allow a particle past to be influenced by future measurements. While this isn't time travel in the sci-fi sense, it does blur the lines between past and future in fascinating ways. Some researchers are even using quantum computers to simulate time travel scenarios. It's like playing a video game where you can be in multiple timelines at once. Not quite time travel, but perhaps the next best thing. And there you have it, the mind-bending world of time travel science. While we are not likely to be hopping into time machines anytime soon, the physics of time travel opens up fascinating questions about the nature of time, causality, and the structure of our universe. From the real-world time dilation of fast-moving clocks to the speculative realm of wormholes and closed time-like curves, exploring these concepts pushes the boundaries of our understanding. Who knows? Maybe someday we'll crack the code of time travel. Or perhaps we already have, and our future selves are watching us right now. In any case, the next time someone tells you time travel is impossible, you can tell them that time will tell in physics. The jury is still out. Thank you very much for watching this video. I hope you enjoy exploring time travel, science fiction, or future reality in this video. The mysteries of time continue to challenge our understanding of physics. Stay curious and keep questioning the possibilities of the universe. See you guys in my next video. Thanks again for watching. Bye bye.